review simplifying radicals. You should have learned this last year in algebra, but we need to review it so that you can use it in the next couple of topics you're doing. So a radical expression is an expression that contains a radical. Makes sense, right? So what is a radical? It's this, and it can have any number here, but the only one we're going to deal with is a 2. But when the 2's missing, it's implied, kind of like that imaginary 1 that you see sometimes in front of x or as an exponent. So when you see this without the 2, without a number, it's square root, which is the only one we're going to deal with in geometry right now. So we're dealing with a radical or square root. You can call it either one. A radical expression is in simplest form. That's what we want, simplest form, when 3 conditions are met. First, no radicals have perfect powers as factors. We'll talk about that in a moment. No radicals have fractions. That means you can't have like a fraction under a radical. No radicals are in the denominator. So you can't have like a number here and a radical here. So these are the things that we need to make sure of. Okay, first we can simplify them with what we call the product property. That means that the square root equals the product, that means multiply, of the square roots. For example, if you have, this is not a good example, if you have square root of 45, that is equal to, what can you split 45 into? 9 times 5. So that is equal to square root of 9 times square root of 5. So it's all of this has equal value. But I know the square root of 9, it's 3, because 9 is called a perfect square. So I drop the radical and actually do the square root and get 3. But square root of 5 stays under the radical. So with numbers, I do that. With letters, square root of AB equals square root of A times square root of B. You can always split it up. So let's simplify things using that property. Now, I could make this the square root of 2 times 12. Does that help me at all? No, because I can't simplify these. So let's try something else. I could make it the square root of 3 times 8. Does that help me at all? No, can't simplify those. So let's make it the square root of 4 times 6. That helps me because that's the square root of 4 times square root of 6, and I know the square root of 4. Square root of 4 is 2. So 2 square roots of 6. That is the simplest form. That's how you simplify it. So rule number 1 we learned over here was that no radicals have perfect powers as a factor. So here, 4 is a perfect power. So what are our perfect squares? In case you don't remember, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Perfect squares are numbers that the square root of them is a whole number. Square root of 25 is 5, square root of 36 is 6, etc. So let's say that you don't remember your perfect squares. You can go to your calculator and go hit the y equal button, put x squared, go second table, and it will list the perfect squares for you. Now, I've told you this right down here in case you need a little reminder that this is the way the calculator can help you if you don't know your perfect squares. So what I'm going to do on this one is I want to see, can I split it into the product of a perfect square and another number? Well, what if you don't know your factors of 108? You do this. You go to y equals, you put the number. I wish I could pull up my calculator on the screen for you, but I can't. So we're just going to, you're just going to hopefully do it with me or imagine. So in y equals, you're going to put, where are we? 108. Sorry, give me a second to make my calculator work. 108 divided by x, then you go second graph, and you've got a list of factors. So you're going to have the x, you're going to have the x and the y when you go to second graph. So you're going to have 1, 2, 3, etc. But what you're looking for is you're looking at the y column. You start at the top and you go down till you find the biggest perfect square. Well, 108's not, 54 is not, 36 is. That's your biggest perfect square. So we're going to go 36 times 3. Because right here, you see that 3 times 36 is 108, but 36 is a perfect square. What is the square root of 36? It's 6. Square root of 3 can't simplify. There's your answer. So doing another one, let's look at this one. I know that I can make this one square root of 25 times square root of 3. Square root of 25 is 5. 5 square roots of 3. Now, when the radical's in the denominator, you have to do what we call rationalizing. You have to rationalize the denominator. What that means is you want an integer in it. You want to eliminate the radical. No radical in the denominator. So, remember how you can multiply both the numerator and the denominator by the same thing and it be equivalent? Well, we're going to do this. We're going to multiply both the numerator and the denominator by the radical that's in the denominator. So here we go. Let's look at an example. So we have a square root of 5 in the denominator. We don't want it there. So we multiply it by itself. But what we do to the denominator, we must also do to the numerator. Now, square root of 5 times square root of 5 is just 5. That's why we did that. It gets rid of the radical by definition of square root. Square root of 3 times square root of 5 is square root of 15. 15 can't be simplified. There's no perfect square that divides into it. That's my answer. I got the radical out of the denominator. Let's look at another one. I multiply by the radical that's in the denominator. Square root of 2 times square root of 2 is 2. That's the whole reason that we did that. 8 square roots of 2. So square root of 2 can't simplify, but 8 over 2 can. 8 divided by 2 is 4. So this one simplifies all the way to 4 square roots of 2 and got rid of the fraction. One more. Let's look at this one. Square root of 2, square root of 2. So now I have 10 square roots of 6 over 2. This simplifies the same way the other one did. 10 divided by 2 is 5. There's my answer. And change my mind. One more. Square root of 7, square root of 7. So this one is square root of 7 over 7. You can't simplify that any. That's our answer.